Okay. Logistic regression and the Adaline algorithm demonstration. The first one, provide the sample output from the one test and showing the classification performance. So here is my output. This is the actual class and this is the predicted class for the iris data set, and this is like the output of one test set. I'll be showing the performance later in the third demonstration. Show the trained logistic regression model and the demonstrate the weight and demonstrate the gradient descent. So here is my output. The weight is initialized with the random number with the uniform, basically uniform vector, and then starting the iteration 0, delta weight is initiated with 0, and then linear prediction is made for the each class. Softmax calculation is done for the each class, and then adjusting weight for the class 0, class 1, and class 2. So in that way the calculation is getting repeated for each instance, each instance, and then finally uh, so over here we were basically, and then finally if we come down, the algorithm does converge at the 546 iteration, and this is the final weight, trained weight overall, and this is the difference. So 0.05 is my the cutoff convergence criteria. So and we can see the all the weight updation and the vector updation is happening over here, delta weight calculation and etc. Moving on to the next one is the like the average performance on the five-fold for the logistic regression. I will be executing the algorithm, and it will take a little bit of time to go through the all, but it started coming for the first one. So I will pause for some time and we'll be back in a minute. Okay, all the five-fold executions are complete, and here is the output for each iteration, how much for each fold, how many iteration it took, and the accuracy. So we can see like it is almost around between 630 to 690 the number of iteration, and this is the accuracy 9.96.1.0 etc. And the overall five-fold average accuracy for the logistic is 0.96. Okay, moving back to the Adaline algorithm. So show the sample output and the test set on the classification performance. Here is the output. On the right side, we can see that this is the actual class and this is the Adaline predicted class. So almost like this is a pretty good accuracy. So we can see the both class are matching. Later on, I will show the average accuracy of across the five-fold for the Adaline algorithm. Moving on the show the trained Adaline model demonstrate the weight update and the gradient calculation. So here is the calculation. If I go up over here, I just printed for the five iteration. The first thing it is doing it for class 0, and then later on it is doing it for the class 1. So if it is a multi-class, it is doing for as number of classes. So initialize the weight with the random vector with the uniform number, and then for the iteration 0, doing a linear prediction and the error calculation, and then updating a weight. And then for the each instance it is doing it. I am printing for the five instance and then moving on the second iteration basically, not printing all the instances basically. So in that way we can see the number of iterations are changing, and the linear prediction error and weight update is happening. So at last, just printing the final weight for the each class. So class 0, this is the vector for the uh, weight, and this is the vector for the class 1. If it is a multi-class, we'll have a vector for each class that will be required for the prediction. Moving on to the average performance for the across five-fold, I just executed the algorithm and will and we'll be back in a minute till the execution is complete. Okay, I think I should be done within the 5 minutes of all the five-fold accuracy. We are almost done for the four. Yeah, so we can see that this is the average accuracy across the five-fold. And sorry, each accuracy for the five-fold, each fold, and this is the average accuracy for the Adaline. So that's the performance of the Adaline algorithm for the breast. Uh, which breast cancer, I guess. But yeah, breast cancer basically. That's all. Thank you very much.